Hey guys, in this video we are going to be talking about how to divide involving complex numbers, and we'll start off by doing one with just an imaginary we'll be dividing by, and then we'll move on to the complex. So this number here, we have a complex number on top and we're dividing by an imaginary. The reason why we don't like this being in this form is we can't identify the real and the imaginary part of the number. We're not in the form a plus bi. In this form, you can identify the real and the imaginary part a lot easier than in this form. This is a pain. So in order to do this, what's stopping us from being in this form really is this I in the denominator. So we need to figure out how we can get I out of the denominator. And in order to do that, well, let's think of what we know about I. We do know in the past from I, if you multiply it by itself, you get I squared, which is -1. We're no longer writing in terms of I, we're in a -1 here. So I'm going to multiply the top and the bottom here by I. So 6I times I, and that's going to get us, I'll just write it out, 6 times -1. And then on top, you're distributing an I. So -3I plus 10 times, you're going to end up with I squared. And then we can go to this. So obviously we have a -6 on the bottom. And on top, we have -3I. And then the I squared is -1. So you have a -10. So you have -10 minus 3I all over -6. We can simplify that. And we'll end up with 10 plus 3I all over 6. What you could do is multiply the top and bottom by -1. Get all these signs to be positive. And then this would be our simplified form here. And we like this because we can identify the real part. The real part would be 10/6 or 5/3. So there's your real part. And then your imaginary part would be the 3/6 or 1/2 here. So it's really getting into this form, getting the i's out of the denominator. Which if you just have something like a purely imaginary number down there, you can just multiply the top and the bottom by I, and the I will go away down there. Our next is going to be a little bit different though. And in order to do our next few problems, when we have something that is complex in the denominator, we're going to need to take the conjugates. Just like when we were rationalizing denominators, or you were rationalizing denominators in Algebra 1, we're going to do something very similar when we're working with complex numbers. So if you have a complex number, a plus bi, the conjugate is just going to be a minus bi. So you'd multiply by the real part's going to stay the same, and the imaginary part's just going to become the opposite. If you had a minus bi, the conjugate would be a plus bi. So this is what you started with. These are the conjugates for each one. And that's what we're going to need to get the i's out of the denominator. So our first one we want to look at, we have 4 over -3 minus 6i. So in order to get this in the right form, in order to get the complex in the numerator here, we're going to multiply everything by the conjugate of our denominator. So -3 plus 6i. -3 plus 6i. Then if we're doing the top, 4 times -3 is -12. 4 times 6 is plus 24i. In the denominator, you're going to have -3 times -3 is 9. You're going to end up with a -3 times 6i, and then you'll have a -3 times -6i. You'll have a positive 18i and a negative 18i. Those will cancel. That's the purpose of the conjugate here. So I'm not going to write that middle term. But then you will have -6i plus 6i. You're going to multiply those two together, and you'll end up with -36. The I squared. The I squared again is -1. So you'll end up with a plus 36. And then all we have to do is simplify a little bit. 9 plus 36 is 45. This is the right value, but we can simplify. If you look at your two terms on the top, you have the 12 and the 24i. See if they have anything in common with your denominator, and everything has a 3 in common here. So you would end up with negative 4 plus 8i over 15. And that would be your final value here. And again, it's a little easier to identify the real part and the imaginary part of this. Alright, our next one. Now we're going to have an imaginary divided by a complex. So we have 8i over negative 1 plus 3i. And we just need to get this I out of the denominator, and we can use the conjugate to do so. So we'll have negative 1 minus 3i, that's your conjugate here. We'll multiply the top and the bottom. So let's do the top first. We'll end up with minus 8i, and then 8i times negative 3i would give us a positive 24, believe it or not. You'll have negative 24, and the I squared gives you a negative 1, so it'll become positive here. On the bottom, we'll have negative 1 times negative 1 is 1. Those two middle terms are going to cancel out, and then we'll end up doing 3i times negative 3i, which will give you negative 9i squared, which will end up being plus 9. So we'll end up with 24 minus 8i all over 10. And now look to see if our terms up here have anything in common with the denominator. Looks like everything has a 2 in common. So you'll have 12 minus 4i all over 5. And there you go. We have now divided. We have just i's in the numerator, so we're okay. Alright, in our last one, we'll just do a complex divided by another complex. So negative 4 plus 10i all over 3 plus 4i. And we want to get this to be in that form that we've seen in the others. We want to have a complex up here and then something in the denominator. And let's go ahead and use our conjugate. So 3 minus 4i and 3 minus 4i, there's our conjugate. Let's go ahead, on top you're going to have negative 12. And let's see, negative 12 plus 16i plus 30i. And then you'll end up with, at the last term, a plus 40. You'll have negative 40 times I squared, which is negative 40 times negative 1, so plus 40. On the bottom, you'll end up with 9. And then again, you're going to have that minus 12i plus 12i, they'll cancel, but you'll have a plus 16 as your last term. 4 times negative 4 is negative 16, but you'll have I squared, which is negative 1, giving you the positive 16. So on bottom, we can simplify that to a 25. And on the top, we can simplify right below. Negative 12 plus 40 should give us a 28. 25 on the bottom. And then 16i plus 30i is plus 46i. And just like that, we're all done. And complex in the top, we have a number in the denominator, no i's in the denominator. We also, for all of these, could have written them like this if you want to. I prefer them like this. Especially this one's messy like this. This one's really messy. But it would identify the real part and the imaginary part right there for you. But again, I prefer it in this form here. But this is still the same value. Alright, so that's all we have for dividing involving complex numbers. You can go ahead and try some of these on your own now. Key things to remember, you want to get all the i's out of the denominator, so use your conjugate to do that. Alright guys, enjoy the rest of your day.